Last video on simplifying radical expressions, but what we're going to be doing is adding and subtracting expressions involving variables. So I just want to remind ourselves here that when we want to add and subtract radicals, they have to be what we call like radicals. So just like we have like terms, like if I had a 5x plus a 6x, of course, I would say that these are the same types of things right here. So what I could do is I could just call this 5 plus 6 of these x things, which is really just, we know, 11x. So if I were to say 5y plus 6y, I don't want to like make this any harder than it needs to be. I'm just looking for 11 of these square roots of y, or yeah, square root of y. So when I look over here and we say, well, okay, well, I'm looking with rational exponent i's on here, it really means we are dealing with radicals, okay? So I could rewrite, I say 2x, you know, this would be the cube root of y. There's really not a whole lot of point to doing this, but I want you to see that these are the same thing. So we say that these right here are actually like radicals, and I could have said this to begin with. If they both have xy cubes, then I have 2 here, taking away 7 of these here. We get negative 5 of these xy, you know, cube root things. I said cube last time, but I meant cube root. So when we look over here, we say, are these like radicals? Well, these two are not like radicals, but the thing I really want to point out is that sometimes you're going to have to do a little bit of simplifying on your own first. So first of all, is this radical as simplified as it could be? I mean, that is, are there any perfect cubes in here? And I notice that I have 5 to the first. That would be as factored as it could get. But we say x to the fifth. You could take out one group of 3 x's here. So we say 3 times one group of 3 x's, and this would be taken times the cube root, and we'd have left over, we'd have 5 left over. We took out 3 x's here, so we say x squared is left over. Now we're subtracting off. Looking at this, we say 40. Now what do I know about 40? It's 4 times 10, which is 2 times 2 times 2 times 5, so 2 times 2 times 2 times 5, which its prime factorization is 2 cubed 5 to the first. So we'd say if I were to simplify this expression here, this would be x, I'll go ahead and write this out. We say cube root of 2 cubed 5 to the first x squared. The thing here is this. You notice that I have 3 2's here, and I'm taking out groups of size 3. So now I end up with this. I'm going to rewrite the whole expression. We say 3x to the first, okay, times the cube root of 5x squared, minus, now I want to be left over with this 5x squared here, and you can see how we get left over with this, but we'd say if I had 3 groups, let me try to talk here. If I had 3 2's, and I'm taking out groups of 3 here, okay, I can make one group of 3 2's. So we'd say I'll take that out front, 2 to the first, and I'll multiply it by the x that was already out there, and we'll take this times the cube root of what was left over, which was no 2's were left over, and this is times 5x squared. So this right here, I just will say this is the same as 2x. You know, you can say x2. But if I had 3x, you know, cube root of 3, 5x squared, you know, sorry, cube root of 5x squared, and then I had like 2x, cube root of 5x squared. The thing is, they both have a 5x squared that is being cube rooted. So really what we're asking is, combining like terms, we say, well, 3x minus 2x, what do you get here? You really get 3x minus 2x. I'll show my work, but really you just 3x minus 2x is x. So we get x cube root of 5x squared, and this would be simplest form.